And thanks, Stefan and Matt. Welcome everyone to day 3 of Data World. And I hope you had a fantastic first and second day. So the pressure is on me to give you a nice start for day 3, and I will try my best. So I was looking at like what to talk about in the welcome note. So I looked at all those sessions today, and particularly the very next one, which is after me. So then that gave me the idea what to talk about. So what I will talk about is Alexa and computer science, right? And everybody is familiar with both the things. Alexa is the Amazon Alexa I'm talking about, and computer science, I don't have to say anything. Okay, so let's get in. So this is the famous picture of Alexa, and if I have to talk about what is inside this, so very obvious thing will be like it has a microphone because it can hear you. It has a speaker, which is like very obvious, and it has a Wi-Fi connectivity. Without Wi-Fi, it doesn't work. So it needs to call home to Amazon servers to get the data or to send the data, and that is how it works. But it has one more thing. It has a microcomputer inside. And now, with that, one of the most important thing it does with microcomputer is that whenever you say Alexa, you can see that blue light, it wakes up. So that is the command it interprets, and then it starts recording after that. So before that, it is not recording. There was some controversy, so leave that aside. But when it wakes up, then only it starts recording. And that is controlled by the mini computer. Mini computer does a whole lot of other things as well, like your timer and other things, which it doesn't send to the server. It can do locally. But most important thing is to wake up with Alexa. Now, the word Alexa is a sound wave, which it gets because the microphone, that is what it captures. And you must have heard, right, that people calling it in a very different forms, like Alexa is what it is, but you must have seen the kids shouting at it, Alexa from a very far off, and so on. And different people with different accents and different geos all over the world, it is there, and the same Alexa is there. People can say Alexa or any different kind of pronunciation and different way of calling it. But it understands everybody, right? What Alexa understands at the end of the day or inside that mini computer is 0 and 1. It doesn't get the wave. It doesn't get the analog signal. It is all 0, 1. And this is what it interprets, Alexa, right? So it has to get it. So how does all these different forms converge to this? Right? Because they have to, otherwise the computer cannot understand, or Alexa cannot understand what is being called. So all different pronunciation, all different ways just converge onto 0 and 1. And from a sound wave, you can make out that it can't converge. So how does it work? So let me take you to the famous cat example that how do you make computer recognize cat, right? So you take a picture and you give it to the computer and tell, oh, this is a cat. Now you take another picture and ask the computer, what is this? Computer will most likely tell you that, not sure, I can't make out what this is because it's not exactly matching what was the picture was giving. It's like just the face is there and so on, so and the rest of the part hidden. So it'll just say, I'm not too sure. But if you give a lot of pictures to computer and then say that all are cats, right? And then you ask, what is this? The computer will say, okay, I think with 58%, that is just a made up number, 58% confidence I can say this is cat. Still, I'm not 100% sure that this is cat. That is what the computer will tell you. Now, when the Alexa word is called out, this is what happens. So all these, it has to converge, and the computer has to be sure. At times, it can't be. Probably some of those accent, or from some people, it might not still be recognizing. And all these photos are from stock photos, and that already has these algorithm. You give a picture, it'll go and figure out what is, like all the cat pictures I downloaded. I just typed cat. I didn't say it, I didn't speak out, but from text also it interpreted and then gave me all the cat pictures. So you can see that the computer is working with fuzziness. It's no longer 0 and 1. It is working with probability. It is working with percentage, right? And that you don't associate with computer. But that is the next level of evolution of like whatever the computer can do. And this is part of the machine learning. So the machine is learning and it's getting better. So it is not 100% sure, but more and more it works, more and more it learns, it will get better. And the same thing is being applied. Like as the Alexa is learning more people speak to it, more kind of, it will keep getting better over time. Right? That is what machine learning part of computer science is. Like moving ahead, this is like asking about the weather to Alexa is one of the most common things. And the common questions are like, hey Alexa, Alexa, what is the weather today? Or if people could be like, okay, what is the weather in my city today? And different ways kind of people ask. Now, this is a different dimension. What does computer understand? So the language which computer understands is something like this, which is like Java, Python, or Node.js, and different kind of things. C++ from a little earlier times, and so on. That is what computer understands. It is a very finite kind of a language. It's written, so there is no ambiguity and so on. That is what it understands. But now it has to work with the human language. How does it work with the human language? So there is a study within computer science. It's called natural language processing. And there are variants of that is natural language understanding. If the computer is understanding what you are speaking, that means that is part of that sub-branch of that natural language processing. And now the Alexa has to speak back as well, right? So the language has to be generated as well. So it's a natural language generation. So this is what the part of the computer science, which is like very important, which is kind of running everything behind the scene. It is interpreting or understanding the human language, what you are saying. And it hasn't been easy. So NLP in a short form has been there for decades. Turing started at 1950s, early 50s, and there is something called Turing test, which say the machine if passes that is understanding that human language. And the initial these things were all rule based. So if let's say any sentence is there, you break it up into parts of speech. Or this is noun, this is verb, this is kind of a pronoun, and this is adjective, and so on. And that is what it tried to kind of understand the language. Then it evolved a little bit. Then it was like a subject and predicate, and that is how it tried to interpret that language. But what happened was, if you kind of break it up and then try to understand the grammar and tense and other things, so it's kind of a decision tree. So you keep writing if this, else this, and so on, and it kept getting too cumbersome, and it didn't kind of evolve for decades. Talking about 1950s started till late 90s and so on. It just couldn't evolve. Because it was like, and then it was very limited to whatever language it is. Like it is restricted to English. If you want to make it learn French or do everything for French or German, then you have to go through the same whole process again to do that. Then the statistical model came where you group things together and then say, okay, this is what it is, like bunch of things together, and then you associate a probability to it. And then there was a rapid evolution because it doesn't kind of get bogged down by the English or French. It just learns over time, and the machine learning combined, it became very, very rapid. So machine learning with the statistical model gave a very rapid rise to natural language processing, and that is what suddenly you see last decade or so, all these lot of tools which are available, they are like kind of rising with it. So you see Cortana, Siri, various form of chatbots, Google Home. They're all using the same kind of a same technology and same thing running behind the scene. And then it is evolving in a different direction that it can just not just understand, it can do various things. For example, in a support environment, the chatbot can fetch your ticket, it can file ticket for you, and so on. So those are like core computer science thing anyway the software could do for ages, but understanding the human language, that is a new thing, or speaking human language, that is a new thing. From Adobe side, like Adobe Sensei is our AI platform which is running behind the scene for Adobe Stock, Adobe Experience Manager, your sentiment analysis, your auto tagging, whole lot of kind of every application within Adobe, they are like kind of integrating with Sensei engine and then providing that the experience and that feedback to our users, right? So I think this is a good segue to the next session, which Keith is going to talk about. And he has a topic on chatbot, AI. So I tried to give a little bit of background so that you understand his session better. And I love talking about technology, but just 15-minute, I couldn't tell you more stories and more things. But whenever I get a chance next, I'll definitely talk more about it. And today's the third day, and wish you all the best. Have a great session. We have, as Stefan kind of spoke, we have a great lineup. And thanks, and have a